Good morning, ladies and gentlemen. I'm here this morning to give you an overview of our Walmar House Project, which coincidentally had been Erith's London head office between 2009 and 2011. The project was located on Regent Street in central London and was completed on behalf of our client, Great Portland Estates. The project had some very unique temporary works engineering incorporated into a complex cut and carve demolition phase that also included civil demolition basement works occurring simultaneously. Once this was achieved, once a revised engineering package had been agreed with the client's design team. Walmar House is located at the north end of Regent Street and spans the blocks between the corners of Great Castle and St Margaret Street. Regent Street, as I'm sure you are aware, is one of the major shopping areas in London's West End, well known to tourists and Londoners alike, and famous for its Christmas illuminations. It is named after the Prince Regent, who became George V, and is commonly associated with the architect John Nash, who penned the original architectural designs in the early 19th century. Although all of these buildings were subsequently demolished and later replaced with new buildings between the late 19th and early 20th century, the street layout still remains as he penned in the early 19th century. On average, Regent Street sees 250,000 pedestrians pass along its street on a daily basis. Originally built between 1910 and 1925, Walmar House consists of a steel frame structure with hollow pot floors, a mansard roof and a single-storey basement. The structure is Grade 2 listed and has a Portland stone facade. The scope of Erith's work was to demolish the late 1920s rear annex, the roof structure and the rear section of Walmar House, retaining the facade and the first bay of the structure to the 3 street levels. However, there was an element of the facade that was removed from Great Castle Street to give a clean cut line between the adjacent building. The works were required to be completed and incorporating the tight site constraints of a central London location. Under the original scope, the client's design team had suggested a sequence for demolition and provided a location that they required the tower crane base to be set out in for the future construction works. Undertaking the works in this fashion would have seen the rear annex of the structure requiring demolition first. The arisings produced from the works would then have had to have been transported through the remaining structure by hand and into a gantry located on Great Castle Street before arisings could be loaded into waiting lorries. So Erith, in conjunction with our in-house design engineers, Swanton Consulting, ensured that the demolition phase would be intrinsically linked to the design of and installation of the temporary works. In order to facilitate the demolition of the old structure and prepare for the new structure, we had to design and install a variety of temporary works items. The most obvious of these was the tower crane foundation. The crane was needed early in the programme before the excavation of the substructure was to start. As such, Erith designed a regime of structural investigations and testing to enable us to develop a strengthening strategy for the existing stair core steelwork to allow us to use that steelwork of the stair core as a foundation for the base of the tower crane on a grillage with additional ballast. The placing of the tower crane on the existing stair core became the unique element that stood Erith's approach out from our competitors. As the building facade was to be retained, there were 2 distinct strategies adopted. The first was to provide an external facade retention system, which enabled the structure to be entirely removed behind the facade. This system used lightweight steel trusses to span between 2 remaining walls inside the building. The second approach was to retain a single bay of the structure internally to use the remaining floors of the structure to stabilise the facade. However, a consequence of cutting back the building to a single bay from the facade was that the existing stability cores became detached from the retained structure, and so we had to provide an alternative arrangement to stabilise, to act as stability bracing behind the demolition works. Whilst the structural arrangement of the building could be determined from investigation, we were unable to accurately determine the in situ strength of the structure, which was needed to determine the size of demolition equipment that could be used on the floors. So we implemented a series of floor loading tests, which loaded the floor to determine the safe capacity. Now, this exceeded the capacity that we could justify from the original designs and standards used at the time of the original construction of the building. We also designed and installed a range of measures to assist the demolition. There was propping to leading edges and to cut lines where the permanent support was removed. Similarly, we provided a series of runways and resilient platforms to allow heavier plant to be run on the first floor slab to load waste vehicles, which run on a strengthened ground floor platform. There was a requirement to transfer load between the existing walls and the new framed element, and we designed a series of stalls that enabled us to form cutouts in the wall for the steelwork installation and jacking without the need for a two-storey needle arrangement. In all, there were over 400 props and 60 tonnes of temporary steelwork positioned inside the structure during the project. To enable waste segregation to be maximised, Erith, we undertook a variety of structural and internal surveys prior to commencing work. Following the initial survey, which was the Asbestos Demolition Refurbishment survey, our in-house team removed the asbestos that was required. Following this, the phased soft strip works saw fixtures and fittings being removed and placed into segregated stockpiles at each floor level. Openings were then made in the roof and the subsequent floor levels to allow the tower crane, which had been erected earlier on the stairwell steelwork, to be utilised with a boat skip to remove the arisings from the floor out over the building onto the loading gantry in Great Castle Street. Having the tower crane available at this early stage maximised our segregation of arisings and helped us to generate a figure of 98% of all arisings and materials removed from the site, either being reused or recycled. Demolition of a structure such as Walmar House in a central London location has a host of contributing factors that must be taken into account. The City of Westminster, along with our client, required a strategic traffic management plan to be put in place. This meant that no deliveries or waste material collections could be undertaken by more than one vehicle at a time. So vehicle movements were planned meticulously on a daily basis to ensure that this occurred. Key stakeholders, including site neighbours, required planned interface and coordination to ensure that we kept them informed of works being undertaken and to ensure that minimal disruption was caused to them. We utilised our internal neighbourhood liaison team to ensure that the constant flow of information was maintained to these key stakeholders. Through the engineering innovation with the tower crane installation, disruption to the local area was reduced by 12 weeks on the initial client's programme of works. There was also asset protection taken into account in the form of the Portland stone facade. We utilised a fully enclosed monoflex sheeted scaffold with further internal items of the structure being protected by timber shrouds and protective wrapping. As part of the project, our Safety 24/7 behavioural culture played a fundamental part in delivering the project to the high expectations of the client team. Encompassed within this was our standard suite of environmental monitoring, which included real-time dust, noise and vibration monitoring, with all results being fed directly back to the client and key stakeholders. To complete the full scope required for the project, Erith undertook a 12-week civil demolitions and reinstatement works package. This included the removal of the basement slab, reduced dig and removal of subsoil from the site to the area of where the rear annex had been. Further to this, a new lower basement slab was required to be constructed, which in turn incorporated the new drainage scheme for the construction phase works. With the installation of the new tower crane base now not required, and the use of the tower crane during the soft strip and demolition of the roof and rear annex, the phase civils element of works could be brought forward. Thus, both structural demolition and civil works were completed in tandem, as I said, giving a 12-week programme saving to our client. Overall, the Walmar House project had a combined value of just under £2 million, and at its peak we had a workforce of 25 operatives working within the site, within the confined space area. The project was completed with 0 reportable incidents and contributed 35,000 incident-free hours to our health and safety statistics for 2012 and 13. The project saw some 6,500 tonnes of material and arisings removed from site, of which this was transformed into 6,370 tonnes of reused and recycled material. Finally, the project was delivered by Erith with the client's budget within the client's budget, and with, as I say, with the 12-week saving on their programme. And thank you very much. Any questions?